When determining the appropriate electrical setup for a basement, several factors need consideration. These include calculating the load for lighting circuits and understanding the requirements for receptacle circuits, particularly the 180 volt amps rule. Firstly, regarding lamp and circuit load, yes, you are correct in using the lamp's rating to determine the circuit load. If you have 1675 watt lamps, the calculation is as follows. 16 multiplied by 75 watts equals 1200 watts. Then 1200 watts divided by 120 volts, which is the typical circuit voltage, equals 10 amps. This confirms that a 15 amp circuit can indeed support the load of 1675 watt recessed lights. Now let's address receptacles and the 180 volt amps rule. The 180 volt amps rule is a minimum requirement set by the National Electrical Code, or NEC, for branch circuits serving receptacles. This rule essentially means that each receptacle outlet should be capable of handling a load of at least 180 volt amps. It's a safety measure to ensure that the circuit can accommodate various appliances and devices that might be plugged into those receptacles. The NEC permits a maximum of 8 receptacles per branch circuit when using this 180 volt amps calculation. Therefore, in a typical residential setting, if you're adhering to the 180 volt amp standard, you can have up to 8 receptacles on a single branch circuit. For a basement wiring project, it is recommended to follow specific guidelines to ensure safety and compliance. Regarding lighting, installing 16 recessed lights on a single 15 amp circuit, as calculated earlier, is acceptable provided the total load does not exceed the circuit's capacity. For receptacles, adhere to the standard of 8 receptacles per branch circuit, each rated at 180 volt amps. This setup allows for a reasonable number of outlets while maintaining a safe load on each circuit. For example, if you need a total of 16 receptacles in the basement, you would need 2 separate branch circuits, each serving 8 receptacles. There are additional considerations to keep in mind when undertaking any electrical project. Firstly, ensure that the wire size and the circuit breaker used are appropriate for the load they will carry. The American wire gauge, or AUG, standards dictate the ampacity, or current carrying capacity, of different wire sizes. For instance, a 15 amp circuit typically requires 14 AWG copper wire, while a 20 amp circuit usually requires 12 AWG copper wire. Secondly, consider the length of the circuit when selecting the wire size. Longer circuits experience voltage drop, which can affect the performance of devices and appliances. To mitigate voltage drop, use a larger wire size, which reduces resistance over longer distances. Thirdly, always consult with a licensed electrician if you are unsure about any aspect of the electrical work. Electrical work can be dangerous, and improper wiring can lead to fire hazards or electrical shocks. A qualified electrician can ensure that the wiring is done safely and in compliance with local electrical codes. Now let's delve deeper into the technical aspects. The calculation of circuit load is a fundamental aspect of electrical wiring. The formula for calculating power, or watts, in a direct current, or DC, circuit is power equals voltage multiplied by current, or P equals volts times amps. In alternating current, or AC, circuits, which are common in residential wiring, the formula is slightly more complex due to factors like power factor, which accounts for the phase difference between voltage and current. However, for resistive loads like incandescent lights, the power factor is close to 1, so the formula P equals volts times amps can be used as a good approximation. When planning the layout of receptacles, it's important to consider the types of appliances and devices that will be used in the basement. Heavy-duty appliances like power tools, space heaters, or refrigerators require dedicated circuits to prevent overloading. These appliances typically draw a significant amount of current and can easily trip a circuit breaker if connected to a circuit with other loads. In addition to the 180 volt amps rule, the NEC also provides guidelines for the spacing of receptacles in residential buildings. The general rule is that receptacles should be placed so that no point along the floor line of any wall space is more than 6 feet, or about 1.8 meters, from an outlet. This ensures that extension cords are not needed to reach any point along the wall. When installing recessed lights, it's important to choose fixtures that are suitable for the intended use. Recessed lights come in a variety of sizes, shapes, and wattages. Some recessed lights are designed for general illumination, while others are designed for accent lighting or task lighting. It's also important to consider the type of bulb used in the recessed lights. Incandescent bulbs are the traditional choice, but they are less energy efficient than other options like compact fluorescent lamps, or CFLs, and light-emitting diodes, or LEDs. LED are the most energy efficient option and have a longer lifespan than incandescent bulbs or CFL. When wiring receptacles, it's important to follow proper wiring techniques. The black wire, also known as the hot wire, should be connected to the brass-colored screw terminal on the receptacle. The white wire, also known as the neutral wire, should be connected to the silver-colored screw terminal on the receptacle. The bare copper wire, or green wire, which is the ground wire, should be connected to the green screw terminal on the receptacle. The ground wire provides a path for fault current to flow back to the electrical panel, which helps to protect against electrical shock. When connecting wires to screw terminals, it's important to make sure that the connection is tight. Loose connections can cause overheating and can lead to fire hazards. It's also important to use the correct size of wire connector for the size of the wire. Wire connectors are used to join two or more wires together. They come in a variety of sizes and types. Some wire connectors are designed for use with solid wire, while others are designed for use with stranded wire. It's important to choose a wire connector that is compatible with the type of wire being used. Before working on any electrical circuit, it's important to turn off the power to the circuit at the electrical panel. This can be done by flipping the circuit breaker to the off position. It's also a good idea to use a voltage tester to confirm that the power is off before touching any wires. A voltage tester is a device that can detect the presence of voltage in a circuit. It's a useful tool for ensuring that the circuit is safe to work on. When working with electrical tools, it's important to wear safety glasses and gloves. Safety glasses protect the eyes from flying debris, and gloves protect the hands from electrical shock. It's also important to keep the work area clean and free of clutter. A cluttered work area can increase the risk of accidents. When running wires through walls or ceilings, it's important to use the correct type of cable. Non-metallic sheath cable, or NM cable, is the most common type of cable used in residential wiring. NM cable consists of two or more insulated wires wrapped in a plastic sheath. It's important to choose a cable that is rated for the voltage and current that it will carry. It's also important to protect the cable from damage. When running cable through studs or joists, it's important to drill holes that are large enough to accommodate the cable without damaging it. It's also important to use cable staples to secure the cable to the studs or joists. Cable staples are small metal clips that are used to hold the cable in place. When installing electrical boxes, it's important to choose boxes that are the correct size for the number of wires that will be contained in the box. Electrical boxes come in a variety of sizes and shapes. It's important to choose a box that is made of a material that is compatible with the type of wiring being used. Metal boxes are typically used with metal conduit, while plastic boxes are typically used with NM cable. It's also important to ground the electrical boxes. Grounding the electrical boxes helps to protect against electrical shock. In summary, when wiring a basement, firstly calculate the lighting load by multiplying the number of lights by their wattage and dividing by the voltage to determine the current. Secondly, adhere to the 180 volt amps rule for receptacles, limiting the number of receptacles per branch circuit to 8. Thirdly, use the appropriate wire size and circuit breaker for the load. Fourthly, consider the length of the circuit to minimize voltage drop. Fifthly, consult with a licensed electrician if you have any doubts or questions. By following these guidelines, you can ensure that the electrical work in your basement is safe, compliant, and reliable. Remember that electrical codes and regulations can vary by location, so it's always best to check with your local building department to ensure that you are in compliance.